These are the first 6 problems on the study guide for Algebra A Test 3, Quarter 2. And so again, this is a great practice test. So I would do these problems and then check these answers. And if you get one wrong, and you're not sure how you got it wrong, then take a look at this and follow the examples that I'm going through to see if you can find your error. So the first problem you're going to see is a solve by graphing problem. So use the slope, use the y-intercept to graph. Here's the y-intercept. And so positive 3, that's where you're starting this line. So up 1, 2, 3 places. And then use the slope. The slope is 1. It's always the number out in front of x. So treat that as a fraction, 1 over 1. So you're going up and then to the right. Now you can also treat it as a negative 1 over negative 1, and that would be down to the left. And you do that a few times, and I would continue doing that to just about run out of room. And then I move over to the next line. And so the next line has a y-intercept. Again, this is the y-intercept because y is by itself. And so I can find the y-intercept, again, due to the fact that y is all alone on one side of the equal sign. So there it is. The y-intercept is 6 spaces up. So I go up 3, 4, 5, 6. Put the dot. And then use the slope. Now this slope is negative 2 over 1. So negative 2 over positive 1 tells me to go down and then to the right. In that first iteration, the first time I do that, I get those lines to cross. So I'll just carry it down a little bit so you can see the 2 lines. But this is the answer. Now, I see some people doing this work but not giving me that answer. The answer is the ordered pair. So 1 space to the right, so it's positive 1, and 4 spaces up. So the answer you need to write down is 1, 4. Put that in parentheses so it represents an ordered pair, and box your answer. Let's take a look at the next one. This is a great substitution problem. It just says to solve the system, so there's no specific method to use, but substitution works well. And so I'm going to take this expression that y is x plus 3 and put it in place of y. And let's rewrite the equation that we have. So now it's going to be 2x plus y, but in place of y, we put the expression x plus 3, because that's what y equals. This all equals 6. So we've got some x's to collect on the same side of the equal sign, and then also an opposite operation. So we'll take that 3 from both sides and rewrite what we've got. So the 2 x's add together to make 3x. This all equals 3. So you do that division, and you'll have your value of x. So x is 1. So once you have one term, you're not done. Some people on the test last week only give me one answer. Well, that's not the answer. We need to go ahead and substitute back in to find the other variable. So y equals x plus 3. But in place of x, we can write 1, because that's what x equals. And so we end up with 1 and 3 making 4. So there's our answer. Ordered pair 1, 4. Always put x first, then y. So same answer we had over here. And actually, these were the same equations, just modified that second one. Well, this is a great elimination problem for number 3. And it's a good elimination one because x's, y's, equal signs, constants, all in line. But I can't add them together the way they're at. I need to multiply one of the equations by some number. I'm going to choose to cancel out the x term first. And so I'm going to multiply every number on that bottom equation by 2. So I'm going to rewrite what I would have the new modified equation be negative 2x plus 6y equals negative 24. Make sure you multiply every number in that equation by 2 in this case. So I'll rewrite this top equation down below. So it's going to be a 2x plus y equals 3. So I'm ready to add these together. I get those x's to cancel. And let's see what we have. So again, these canceled out, so I'm left with 7y equals 21. I had to subtract because they are opposite in sign. So I do that division, and I end up with y as 3. Well, that's just as one term. We still need to find the other part, the other value, which is x. So I'm going to take that 3, put it in place of y in one of the equations. I choose to put it in that top equation. So we'll rewrite what we've got, 2x plus y. But in place of y, we put 3, because that's what y equals. Well, when I do some work there, I'm going to subtract that 3 from both sides. And I get, oh, I've made a mistake already. Did anyone catch my mistake I made? Oh, it was way back here. It didn't hurt the problem a whole lot. Right here, negative 24, positive 3. What's that make? That's not a positive. That's not a positive. That's a negative. I have more negatives than positives. Don't make the same mistakes I make. Make your problems correct. So here I had to have a negative. So that makes y negative 3. So when I substitute in, I should have a negative 3 right here, which means I need to do the opposite of that, which is positive. So from there, caught my mistake right away. I was looking back. I was thinking to myself, oh, I'm getting 0 here. Maybe I should look back and check. And I did, and I saw, oh, there was negatives here. I needed to have more negatives than positives. So anyhow, we bring down this 2x. This all equals 6. Divide by the 2, and you get your value of x at 3. So there it is. Y is negative 3 when x is positive 3. So 3 comma negative 3. Well, just a few more problems for part number 1. And let's take a look at this one. It's another system, but this time I've got to modify both equations. See, I can't just multiply 2 by a number to get 3 or 5 by a number to get 4. So I'm going to multiply this top equation by 3. Bottom equation by 2. And so what I'm doing is I'm eliminating the x terms. So every number up top gets multiplied by 3. So that becomes 6x, becomes a positive 15y, and it equals, now careful on this, it makes 78. And then on the bottom one, it's negative 6x, it's a negative 8y, and it equals negative 50. So now I'm ready to add that together, and I get those x's to cancel. So now these are gone, so I'm just left with y. 7y equals 28. Well, all we have to do is divide now. Divide by 7, and we'll have our value. So y is 4. So I got y now. Just substitute back in. See, this is where it's a little bit more difficult dealing with elimination, because when we do the substitution, we got some extra work to do. I'm going to put in for that y up there. So it's going to be 2x plus 5 times 4. So 5 times by the 4, and then equals 26. Well, this makes 20 right here, so that's what I need to take away from both sides. I'm going to take away that 20, and what I've got left is that 2x equals 6. So I did the 26 minus 20, and that's how I'm getting 6. Well, from that point, we'll just divide by the 2, and we'll have the value of x. X is 3. So there it is, 3 comma 4, the value of that system, the point where the two lines cross. Well, 2 more problems for this part, and this next problem is what? Well, a good substitution problem. Look, y's by itself. Substitution makes the most sense here. I'm going to take that y value and put it right in there and see what we get. Well, when I start doing the work, something happens with this problem. Watch. 3x plus y. Well, plus, and then I'll put in the y value, negative 3x plus 2, all equals 6. What's weird about this? Well, x's are gone now. See, I substituted the y value, and for y, I've only got x's here, but these cancel out. They're gone. And so that means I have no variable. All I have is 2. And 2 does not equal 6. So what does this mean? This means the lines are parallel. I have parallel lines. And parallel lines don't cross. And so if they don't cross, that means I don't have a solution, because solutions are where they cross. So there is no solution. So you'll see that on your test as well, but don't put every problem down as no solution, because that's not the case. only when the variables cancel and the numbers don't equal. Well, here's another problem. Again, a great substitution problem because we can take this negative 2x plus 3 and just put it right there in for y. Let's see what happens. Well, when we do that, we get 2x plus y. But in place of y, put the expression y is. Negative 2x plus 3 equals 3. Oh, lo and behold, look what happened. We end up with the same situation. See, the 2x's cancel out. They make 0 again. And all I'm left with is the constant 3. And that does equal 3 this time. So what does this mean? Well, this means that we have the same line. The lines are the same. And that means every point's a point that crosses another point. So this means we have infinitely many solutions. And that is one way to write the answer. You could also use the symbol as well. And again, that symbol is that sideways 8. And so there's our symbol. More of an 8 there. There we go. Infinitely many solutions would be our answer. Well, those are the first 6 problems we'll take a look at in part 2 of the last 3.